All right, let's pick up from the last video. We did number one. Now let's move on to number two. It says the average purchase by a customer in a large department store the week before Christmas is $120 with a standard deviation of $15.20. If 50 customers are selected at random, what is the probability that their average purchase will be more than $124? Okay, so let's set this up in our bell curve here. And what do we know? Well, we first want to put our mean of the sample means. And we know that the department store has a mean purchase of $120. That's the population mean. And we know that will equal the sample mean, or the mean of the sample mean. So we'll put 120 right here. Okay. Furthermore, we know that the standard deviation is $15.20. So the standard deviation of the population is 1520. But we're not interested in the standard deviation of the population. We need the standard deviation of the sample means, which is called the standard error. And to do that, we're going to take this 1520 and we're going to divide that by our sample, the square root of our sample size, which our sample size is 50 customers. So square root of 50. So if I take $15.20 and I divide that by the square root of 50, I get 2.15. So my standard error would therefore be 2.15. Now I've got my mean of the sample means 120. I'm sorry, I've got the mean of the sample mean 120, and then I've got the standard error of my sample means, which is 2.15. The next step is to find our range for the probabilities we want to consider. And the question says that what is the probability that their average purchase will be more than 124? Well, 124 is up here. So we put that in there, okay? And then what we want to do is find the area above that. Okay, so we'll go ahead and shade this in here like that. I want to find this area. But we can't do that with X bar values. We need Z values, so we can use the Z tables. So we need to convert 124 into a Z value and 120 into a Z value. Well, we know that this is 0, right? Because it's the mean. What is 124? Well, how many standard errors does this lie above 120? Let's find out. Let's take the 124, subtract 120, and that gives us 4, and divide that by the standard error, which is 2.15. If you do that, you should get 1.86. So positive 1.86. Now we can go to our Z table and find 1.86. Let's go down to 1.8 and across to 6. And it looks like we've got this value here, 0.9686. What does that mean? Well, remember, let me just write it here, 0.9686. So we have it for reference. When you have a positive Z value, it's telling you, the table's telling you the probability of getting a value starting from the left tail up to that point. So the probability of getting a Z value all the way from negative infinity to positive 1.86 is 96%, or 0.9686. But we want to know the probability of getting a value above 1.86. So we just take this number and we subtract it from 1, because the entire area under the bell curve is going to be 1, right? Probability is 100%. So if we back out the probability of 0.9686, you get 0.0314. So the probability of getting a value here is 0.0314. And that's the answer to the question. Okay. All right, let's go on to the next one. The next one says the average mileage between oil changes of cars taken to a local quick oil change store is 4,200 miles, with a standard deviation of 680 miles. What is the probability that a randomly selected sample of 45 cars has a mean time between oil changes of more than 4,000 miles? Okay. Let's go back to here. I'm going to clean this up a bit. Let's put in our values. Well, again, we start out with our sample means, and we know the mean of the sample means is going to be the population mean, and it says that's 4,200 miles. And so I put 4,200 here, and we need to know the standard error. Well, the standard deviation of the population is 680 miles. Okay? But we don't want the population standard deviation. We want the standard deviation of the sample means, which is the standard error. So we take this 680 and we divide it by the square root of our sample size, and our sample size is 45 cars. And if you take 680 and you divide that by the square root of 45, you should get 101.4. 101.4. So now we have not only the average for our distribution of sample means, but we have the standard error, the variation of our sample means. And we can then calculate the probability of anything occurring, any event occurring. And for the question, it says, what is the probability that a randomly selected sample has a mean time between oil changes of more than 4,000 miles? Well, 4,000 is over here. So I'm going to put that here, right, 4,000. And we want to find the probability that it has a mean time of more than 4,000. So this entire area here, let me shade some of that in to give us perspective. So I know the probability of getting anything here. All right, there we go. Of course, we can't get probabilities from x values. We need z. We need to standardize these x values. We know that the mean standardizes to 0, and this will standardize. We find out how far this lies from the mean. Well, 4,000 minus 4,200 is negative 200. Right? So negative 200 divided by our standard error of 101.4 gives us a z-score of 1.97 negative. So negative 1.97, which means this value lies 1.97 standard errors below this value. Now let's go to our table. We're looking for 1.97. So we go to 1.9 and then over to 7. 7, so it looks like we're here, 0.9756. And that tells us the probability of getting a value. Remember, we're negative, so we're starting on the right tail, of from here all the way to here. So there's a 0.97. There's a 0.9756 probability of getting this area here, which is actually what we wanted to determine. So that is, in fact, the answer. All right, that's it for this video. If you have questions, let me know.